All right, thank you all for standing by and welcome to today's webinar, Secure Routing and Traffic Management with Ambassador and Consul. Please feel free to type your questions during the webinar. This webinar is recorded and the recording will be made available after post-processing, usually within 2 days. So our speakers today are Nick Jackson, the developer advocate from HashiCorp, and Daniel Bryant, product architect from DataWar.io. And for now, let's just get started. Nick and Daniel, I will kick it off to you guys and make Daniel a presenter.
Great stuff. I'll just wait for the screen sharing to kick in here.
Yep.
Looks good. Oh, I need to move the cameras around 1 second. Oops. So I'll do like intros of who Nick and I are in just a second. Can everyone see my screen okay? Does that look good?
Yeah, looks good.
Perfect. Yeah, so welcome everyone. Thanks for joining us, whether it's early or late where you are. We do appreciate you joining us today. So before I do the intros, I often like to do like TLDRs, and Nick and I have kind of chatted about our core messages we want people to walk away from at the end of the webinar today. So we're seeing a bunch of kind of app modernization, application modernization. People are, say, containerizing, moving to the cloud, basically taking their existing kind of heritage systems, as we like to say. They're not legacy, they're making money, they're heritage. They're taking their existing like heritage systems and putting them into new infrastructure. And the key for like doing this is basically decoupling apps and infrastructure. And that allows you to, say, take advantage of cloud services like machine learning kind of services. You can kind of bin pack stuff. You can also increase security potentially if you containerize things and have a more strict patching mechanism for patching, kind of hermetically sealing things and patching it. But the key for all this stuff is a lot of benefits from modernizing apps, but you need to do it incrementally. And one of the key messages today is you need to do it securely. Now, Ambassador we're going to introduce today. Ambassador is a API or edge gateway that focuses on handling north-south or ingress traffic. Now, Consul, I'm sure many of you know and love from the kind of key value days and from the service discovery. Well, Consul's got a bunch of cool new stuff coming out or come out already now that handles or focuses on handling east-west service to service traffic now, effectively turning into a Consul into a service mesh. So we'll explore some of those features today as well. We've done a bunch of work, myself and the DataWire team, and on the awesome team behind me. I'm talking today, but there's many awesome people, Flynn, Shabam, that have worked really hard behind the scenes, worked very closely with the HashiCorp team, Nick, and many of the team behind Nick, bridging basically, or putting together Ambassador and Consul. And the combination of this kind of handling of north-south and east-west traffic basically bridges and adds a bunch of cool functionality for, be it greenfield or be it apps that are being modernized, bringing these new apps or bringing these apps to the new world. There's a whole bunch of cool things like dynamic routing. So you imagine as apps are moving from, say, VMs to containers, or even just within Kubernetes, say itself, as pods come up and pods disappear, there's a lot of dynamicism in modern systems. You want TLS everywhere, you want to encrypt your systems, and you want a whole bunch of other cross-cutting concerns, both at the kind of ingress point and very much in the service mesh east-west point as well. So this is us. I'm the one on the right, Nick on the left, and Zhang's already introduced sort of our titles, but both Nick and I love getting involved on the Twitters, on GitHub and so forth. You can typically find me, Daniel Bryant UK, Nick Sheriff Jackson. You can hit us up on Twitter, DM us, look on GitHub, LinkedIn, these kind of things. We love to get involved, happy to take your questions after the webinar. Zhang will sort of help us with that, but also you can always DM us or find us in the various Slacks as well online. We love answering your questions. So I'll hand over to Nick for a second. Before we got started on this webinar, we looked at some kind of security statistics, and we found some quite interesting stats, Nick, didn't we?
Yeah, I mean, so the title kind of says it all, but the thing is that the sort of security, I mean, if anybody's been following the news recently, you see the number of vulnerabilities which are just impacting everybody. I think that's safe to say, but the numbers are real. So, I mean, we've pulled these from a few reports, but 214 records containing personal data are exploited every second, right? That's a lot. That's a huge number. And then it goes on because 2.2% of those records are protected by encryption. 2.2% protected by encryption. So what, like 97.8% of records are not actually encrypted. Okay, let's go on. So this is getting worse. 65% of all cases are linked to identity theft. And if you look at a lot of the reports, this is kind of a very common approach. So attackers are not necessarily going after your sort of financial transactions, your sort of credit cards and stuff like that. There is a massive sort of market around just selling identities. And if you can make away a big haul of identities, personal identifiable information, names, addresses, etc., huge. And what does it cost you? Well, on average, about $3.86 million. Now, that's for a sort of the average breach. However, if you're involved in a mega breach and you are leaking like over 50 million records, $350 million. Big money. All right. Still not done. It's getting bigger. So you got a 72% increase in attacks between 2017 and 2018. And we genuinely didn't make these numbers up. This was all kind of pulled out of two really good reports. So Gemalto Breach Level Index, that's a free report. Definitely recommend you check that out and have a read through there. And IBM released a report last year, which is called the IBM Cost of a Data Breach Study. And that really goes into depth into like what is the cost of a data breach, but where are the costs? So things like loss of customers, cost of investigation. It's a really nice report. I definitely recommend picking those two reports up and just having a look for yourselves. You're scared, aren't you? I mean, realistically, you know, we kind of joke around, but security is really serious business. And I think one of the things that we really want to show you today is that we're not going to fix all of your security problems with some of the techniques we're showing in this webinar, but we're going to hopefully show you that you can cover a certain area of them, and then it really shouldn't be too taxing for you to be able to do that.
Right, thanks, Nick. Yeah, so one thing, as Nick's hinted at there, Nick and I have chatted about this a lot. It's genuinely fascinating, but it's a huge topic, security. And if you're just getting started, awesome book by Adam Shostak there called Threat Modeling. You really got to think about defense in depth. So you got to build security into your apps, into your infrastructure, into the way you provision, the way you deploy. This book is a kind of scary book to Nick's point as well, but it's totally worth reading for a bigger picture. Now, we are going to make a bunch of assumptions today. As Nick said, we're focusing more on the communication thing. So we're kind of assuming that you've secured your data at rest, or you're looking, to do that, learning that. You've done the basic kind of hardening of compute, be it running on VMs or be it, running on in the cloud and containers and so forth. We are more interested today at kind of data in motion. And are your communications vulnerable? As we move to more and more kind of dynamic environments, communication becomes even more challenging sometimes. And like I mentioned before around app modernization, as you are bringing in new things to your stack, you're moving to the cloud, or you're even just, sort of refreshing your data center, typically the network heterogeneity increases. You might have a private data center, kind of private cloud, you've got public cloud in the mix, you've got some Kubernetes there. And something that reminds me of is when I learned, I think it was in college or actually I'll move on to that in a second. But one thing I will say here is you're moving very much from a static world into a dynamic world. So, when I started my career, it was very much racking and stacking. And, we used to lock down IPs and lock down sort of clusters and data centers. Now we may be having multiple clouds in the mix, and this stuff is constantly changing, particularly if you're an organization of any size. Like you're constantly sort of refreshing your hardware, you're constantly looking and evaluating different cloud providers. It's a very different world. And what I was going to mention about sort of look back at my college days is it reminds me a lot about the fallacies of distributed computing. And even though I learned it at college, I totally made mistakes on one of my early gigs when I was a developer, not respecting that this classic paper, and it's built on work that goes back many years, but these are the fallacies many of us as engineers make. And as we kind of go more and more dynamic, we're modernizing our stacks. As I've moved to the cloud, I've really seen things like the network is reliable. We think it when we're developing, when we've pushed a prod, it's not. And stuff we're sort of pushing on today, the network is not secure. Definitely the bigger kind of the network space you get, the more chance there is kind of falling down a gap effectively and having some kind of breach there. Topology constantly changing. There's clearly not one admin when you've got the cloud and so forth. And the fallacy number 8 is literally the network is homogeneous. And I'm sure any of you working in organizations, be it from merger and acquisition, be it from just upgrades or whatever, your network is anything but homogeneous these days. There's definitely a move from this kind of, securing the perimeter as well, which Nick will talk about a bit more in a minute. But you've got to assume kind of zero trust model these days that even within your kind of secure network, there could be bad actors, there could be bad things going on. You've clearly got to protect your front door, and this is one kind of meme I quite like. We've got to think about sort of auth, at the front door. You've got to think about TLS, a bunch of things like that, hardening, rate limiting for DDoS attacks, a bunch of things. But critically, what we're going to talk about today with Ambassador and Consul is you've got to combine the things. It's no good having a really strong perimeter if you've got a kind of daft, like sort of side or internal perimeter, I should say, or internal comms. And one of my favorite memes at the moment is in super strong front gate, you just nip around the edge, and once you're in kind of thing. So Ambassador and Consul, this is a kind of spec of what it looks like. You can see it's sort of down the bottom there. Ambassador is the API gateway, where ingress. You can also see like Consul acting as a sort of our source of truth for the data center at the back there. And Consul deployed as a service mesh can basically not only point Ambassador, say, and other services to the location of other services, so effectively doing service discovery and traffic routing, but you can also like secure those links and the communication between the services that you can see here. You're going to be basically deploying apps, typically Kubernetes, VMs, a mix of things. So there's lots of different kind of connections between all the services you've got, all the existing services you've got deployed on bare metal, VMs, these kind of things. So we want a complete solution that handles in the green, kind of traffic coming in the ingress, and the orange, traffic kind of going east-west across your clusters, across your data centers, this kind of stuff. And this is where we will work together quite hard on producing a complete solution. So a very quick summary, like API gateways, call them edge proxies, they expose internal services to end users and they encapsulate the back end. So your users don't care whether you're running Kubernetes or VMs or whatever, they don't really want to see that. We actually probably want to hide it from a security point of view. We want to enforce things like TLS termination at the edge, definitely a minimum TLS. A common attack is to try and downgrade protocols on TLS, so you want to enforce a minimum TLS at the edge. You also want to do some kind of end user authentication, authorization, like DataWire, we do a lot of work with Auth0, Opka, Keycloak, sort of IDPs, centralized IDPs, where we allow people to do sort of log on via social and so forth. And you want to do rate limiting at the edge because you've got a bunch of bad actors potentially hacking your service or just testing your service. In terms of the service mesh, bit of a buzzword, but I think with good reason, there's some really good ideas floating around with the service mesh. Call it proxy mesh, fabric mesh, whatever you like, but it's about exposing internal services to internal consumers. We as engineers want to consume our fellow engineers' services. You want to encapsulate really the infra again. You don't really care if it's deployed on Kubernetes and VMs. You care to some degree, but you don't when you're routing to the traffic. You don't really mind too much. You do want to have things which Nick's going to break down, like MTLS. If I'm talking to Nick's service, like we want to be able to assure that those services they say they are. That makes sense. So the service identity and clearly encrypting the traffic flowing between them as well. Consul's got a bunch of awesome stuff, which Nick will touch on around access control lists, ACLs, and intentions, kind of specifying at a service level who can do what and to whom. So the intention stuff I think is super cool in Consul. And there's a bunch of other cross-functional concerns you want in the mesh, and you want them at a process of your app. You don't want your Java app doing it. You don't want your Go app doing it with a library. You want to pull those things out, and Consul sort of running with a sidecar can do all of those things using, say, Envoy, which we'll talk about, at a process, which is nice. So just a very quick kind of flow through. Imagine we're making a request, we're going through into the gateway, we're then sort of routing off onto other services. Ambassador is actually talking to a sidecar. Consul deploys using the magic of sort of injection to the pods. We can deploy a Consul, Envoy powered Consul sidecar, and Ambassador basically can then route to that proxy, if you like, of the service. It can be many, often you fan out when you kind of do make requests like as an endpoint, say as a public API, you can fan out to multiple services, and you might also communicate upstream to fellow services as well. And again, all of them running sidecars, be they running sidecars in Kubernetes or sidecars alongside in the VMs, just add a process kind of sidecars that your sidecars and the apps are talking securely, typically over like localhost. You want to make that communication link super secure, but all other communication is going sidecar to sidecar in the mesh. You clearly want to secure the edge. You definitely don't want to miss the gap between the edge to the internal traffic. So you want TLS flowing all the way through, and you want to encrypt everything flowing around the mesh as well, be it going in the same Kubernetes cluster or be it going across Kubernetes and VMs. We also want that identity. So I want to make sure that this service knows it is talking to this service. And they both realize, both know and can prove the identity of the other services. And we can do that with X509 certificates and so forth. I'll hand over to Nick now. So I mentioned about Mind the Gap, and Nick's got a lot of good stuff, a lot of good thinking around Consul, around the sort of perimeter defenses. Nick?
So I think one of the key things that sort of I look at when I think service mesh is one of the things that not a lot of people talk about. And I think one of the real benefits of service mesh is that it facilitates a secure approach. But then you sort of speak to people and they're like, well, why do I need a secure approach? I've invested a huge amount of time and effort into my firewall and my perimeter security. And this is kind of the core problem, because when you look at a lot of the attacks which have kind of happened recently, over recent years, they've been an attack which has bypassed the perimeter security. And it's actually, oh gosh, I almost said the classic developer thing, quite easy to do. Let's say it's quite possible to do, right? But the key thing is that a lot of these attacks are looking at things like code execution, remote code execution. So there's a vulnerability in a framework, and this could be your Struts framework. Struts was a big exploit a couple of years back. And what that does is that allows an attacker to execute code on the virtual machine or inside of the container inside of your network. So if you don't have internal security as good as your perimeter security, which is now non-existent, then the key thing is that what they're going to try and do is they're not necessarily looking to directly exploit the service that they got into. What they want to do is be able to move laterally, and this is kind of the key tenet of why you need it to encrypt in transit and to be able to secure network communication between your services. So Symantec, check out their report. Symantec, like, headline feature that attackers are looking to move laterally within services. And to stop them, what we need to do is we need to implement network isolation. Now, anybody who comes from a networking background, this is not going to be news to you. So you've kind of looked at these concepts for as long as there has been networks. The concept of partitioning different networks into areas of risk and to be able to control the flow between applications in the various different partitions is really not news. But just kind of like for those who may not understand the concept, let's just quickly look at network segmentation and service level segmentation. So on the next slide here, we've got network segmentation. So what are we trying to do? So we're looking at the network and we're saying we have applications which are require high protection. That could be things like your PCI environment. And you've got things which are public. So things like your web servers and stuff like that. Now, you don't necessarily want to put your public-facing web servers in the same network segment as your PCI protected data. Because if there is a code level vulnerability which gives somebody access to traverse and move laterally, then they can get access to your PCI based data. So the approach that's been taken, as long as networks have been connected to the internet, and it literally dates back from the invention of NAT, but it's partitioning the network. So you have a router, you have firewalls, and what you do is you strictly control the movement of traffic between the segments. If I have an application running at 192.168.0.1 and it needs to talk to my payment service in 10.1.0.4, I explicitly set that as a rule inside of my network router, and I explicitly configure the firewalls on the host to only allow traffic between that source and that destination. So that works great for network segmentation, but network segmentation really kind of works when you're dealing with an application per machine. And what we're doing these days is we're tightly packing things. We're bin packing multiple applications into single nodes. So you kind of got an amplification of this problem, and you need to look a little bit deeper. So you start to need to think about not necessarily network segmentation, but service level segmentation. I need to be able to tightly control the traffic that's flowing between different applications, potentially on the same node. And in the instance of a scheduler like Nomad or Kubernetes, this is a sort of a very real reality. So we need to take these two approaches. So on our next slide here, we've got a problem. So our problem around network segmentation and service level segmentation is that predominantly what we're looking at is network location. Now, network location is fine if you know what network location is, but most of the time you don't anymore. I mean, we're heavily leveraging autoscale groups. We're using a scheduler. We've got the complexities of overlay networks on top of schedulers. You've got the complexities of NAT between different environments. It's an incredibly challenging, if not impossible, task to be able to sort of tightly control segmentation between networks and services based on location, because you just don't know what those locations are. And we need to think around that. And what we need to do is we need to abandon the concept of location and start to segregate our networks based on service identity. So let's just take a quick look at that. So previously, if I had two network segments and I need services A to talk to services B, I would end up configuring all of these routing rules. Now, the second that the autoscaling group kicks in, the second that the scheduler decides to move some applications around, all of those routing rules need to be recalculated. They all need to be done, and it has to be done in real time. Otherwise, you're going to have outages. What we really want to do is to ignore all of that network location and just say, I want service A to be able to talk to service B, regardless of where that is. It's a much more simple construct to be able to provide an intention of communication as opposed to a fixed network location.
I think on that note, Nick, I'll hand over to you in just a second for the demo. One thing I will say is, at the moment, the sort of the control planes, if you like, are still fundamentally quite different for east, south, and northwest. And Nick will give you a bit of a demo now, sort of the Ambassador integration with console and so forth. And we've got some extra slides here. We're quite tight for time today, so Nick and I will leave the extra slides in so you can look at sort of offline and so forth. But at the moment, the way you configure based on sort of requirements of how the ingress is used is subtly different than how the east-west kind of config goes through. And Nick will run you through that now. So Chang, would you mind swapping over our screens so that Nick now is driving, if that's okay?
Yep, Nick, go ahead.
Thanks, Chang.
Okay, perfect. So what I'm going to do is I'm going to show you a little demo using Console Connect and Ambassador, and hopefully show you how easy it is to kind of wire things together. So I've already got my my console cluster up and running, and I've actually got this deployed to Kubernetes, but it doesn't have to be. You can have it running in a standard virtual machine environment, or if you're extending out to Kubernetes, you can just deploy agent nodes into Kubernetes. But I've got some services running in here. And what I want to do is I want to expose my website, which is a pod running inside of Kubernetes, to the outside world. And I'm going to do that with Ambassador. So what I really want to be able to do, sorry, TL, is to typing and thinking at the same time, is to have TLS absolutely everywhere. I want TLS into my edge. I want TLS between my edge and my Ambassador gateway, and I want TLS between my Ambassador gateway and my application services. And I want that to not just be TLS, but I want to be able to leverage and mutual TLS to be able to do that intention-based security. So I can explicitly state that only allow connections between these two different application identities. So Ambassador runs on Kubernetes, and you've got two components that you need to deploy predominantly when you're deploying Ambassador to Kubernetes. So the first one is the main Ambassador application, and this is your API gateway. And what you can see here, and these are literally just pulled down from the guides on the Ambassador website, really easy setup. But there's not much going on. I've got some RBAC rules to be able to allow Ambassador to figure out what's going through the Kubernetes API. And I've got a deployment, very standard stuff, using the latest version of Ambassador, which just dropped a couple of days ago, so 0.6.1. And I'm going to deploy 3 instances of this. So I'm just pushing out this into a deployment with 3 replicas. Configuring a couple of ports, so I've got HTTP in, HTTPS, and the admin port, and the health checks. Again, pretty standard stuff. Now, when you want to use Ambassador with Consul, you also deploy the Consul Connect edition. And again, this is all just pulled down from the Ambassador website. Simple and single sort of Kubernetes YAML file. I'm deploying the connector. Now, what's interesting as well is with the connector, I can set up all of my sort of secrets and pretty standard stuff. And I'm going to configure a service. So this is just going to be the service which allows connection from the outside world to Ambassador. So if this is your public gateway, you're going to use a type load balancer. For convenience, I'm just going to use node port, but there's no difference in terms of the changes here. What's interesting about Ambassador is the way that you can configure things up here. So I'm defining my Ambassador service, and I'm saying that I want to use the Consul resolver that I defined in my Consul resolver YAML file that I've already got deployed. I'm specifying the address of my Consul server, and when you run Consul on Kubernetes, it's going to set up a service for you. So I can just use standard Kubernetes DNS resolution there. The data center that I want to use is the primary data center. And the optional element here that is highly recommended, but I want to be able to configure Ambassador to use TLS. So all inbound connections and TLS, and to be able to do that, I've got a secret which is deployed to my Kubernetes cluster, and that contains the certificate and the key here. And this certificate and key is actually an origin certificate from Cloudflare. So my setup, I'm using Cloudflare and Cloudflare's WAF to provide me with Edge. I'm then routing that securely over HTTPS to my Kubernetes cluster, and that's all secured TLS, absolutely point to point, no gaps. So let's install that and get that up and running, and we'll have a look at how we can configure Ambassador to allow ingress. So you can use Helm or whatever your preferred approach is, but I'm just going to use kubectl. Terraform, obviously, you've got to use Terraform, but I'm going to deploy my main Ambassador service. I'm going to deploy my Consul connector. and I'm going to deploy my Ambassador service. And I'm going to correct a typo in my Ambassador service because there's nothing like a live demo.
Nice.
Okay, cool. So that's just gonna, well, I was just about to say that's gonna take a couple of seconds to come up, but it's already up. So let me just have a look at my services running on my cluster. So I've got my Ambassador service there on, that's running on Node port. So let me just connect to that and we can take a quick look at the configuration.
Nick, we got a one question from the audience is, can you please increase the font size?
Oh, I can try. Is that any better? That looks absolutely massive for me.
Yeah, it looks great to me.
Okay.
Thanks.
All right. So let me, I'm just going to run. So the Ambassador admin is obviously protected. I'm not opening that up to the internet. So I'm just getting through that through kube proxy, and let me zoom that up for you as well. So I can see the overview of Ambassador, the various different routing tables which are mapped there. So here's my Kubernetes health checks. I don't have any routes right now. And of course, I've got my services and console there. So let's deploy a service. So first things first, let me just open up console. So the service that I'm going to deploy is this one here. So again, configuring Ambassador, I'm going to do configure a Kubernetes service, but I'm going to add the Ambassador annotations. So what I want to do is I want to say, I want to expose on path / my website, so my Emojify website. I want to use the console resolver. So this is going to use console connect. So it's MTLS point to point. The TLS parameter, which was configured in the Ambassador console connect setup, and my load balancer policy. So Ambassador uses Envoy the same way as Console Connect uses Envoy. You've got a number of different sort of configurable options for your load balancer, including the ability to do sort of weighted load balancing and all sorts of stuff like that. It's incredibly sophisticated. But this is just a simple mapping. You can get the full details on the Ambassador website. So what I'm doing is I've got that Emojify website proxy, and you can see that here. It's running in Kubernetes, and it's exposed as a service in console. So let's deploy that and see. Okay, so again, kubectl apply, and I've just called it ingress. So I've created that service. So if I go over to my Ambassador administration, what you can see is I've now got a fourth route. So I've got this route which is going through to the Emojify website, which is my web app. So let's open up that that sort of website. So again, if I was using a public load balancer, I wouldn't have to do this. I'm just using Node port for now. But what you see is you see that upstream connect or disconnect reset before headers, reason blah, connection terminated. Basically, it hasn't worked. But that's by plan, by design. Because what's happening is Ambassador is making an MTLS connection to my other service, my website service. Now with console, what you need to do is have an explicit intention to allow that connection. So the intentions can be configured through the API. They can also be configured through the UI. I'm just going to do this in the UI for now. But as you can see here in my intentions list, there isn't one which lists Ambassador as a source and Emojify website as a destination. You can see that there is an all services one, which is deny. So I'm running deny by default for all my traffic, but let's create that service. Ambassador. And if I get this wrong, it's going to complain at me. To Emojify website, allow. I can put a description in there, but I know what it is for now. And I'm going to hit save. And there you go. It's working now, right? So what's happened is that you've got a two-step approach with the communication security. So originally, before I had that intention, now Ambassador has the ability to present an identification. So the standard MTLS approach, because it's part of the console service mesh. So when Ambassador connects to the Emojify website, it's talking via the proxies, Envoy to Envoy. Standard MTLS approach, you do the TLS handshake. Because you're using MTLS, the destination then says, hey, I need to see your client certificate. The downstream Envoy will send the client certificate, which is an X509 certificate, which contains the SPIFFE ID, which is related to the service identity. It validates that that certificate was signed by its same chain of trust. And if all of that passes, it allows the connection. But you've got a second step, because you don't just have authentication, you've got authorization. And this is really, really important. So with the authorization step, what the Envoy proxy then does is it connects to the console service mesh, to the control plane, and it says, hey, this service presenting itself called Ambassador has just connected to me. Is it allowed? And using this intention graph that we've got defined here, the control plane will say yes or no. Now, it would be incredibly inefficient if that happened with every single request. So it doesn't. You're going to cache your connections. You're going to run a pooled connections, which makes the sort of the process of sending those requests very, very low overhead, very, very efficient, very, very fast. And because of the nature that the local console agents can cache data as well, you've actually got a lot of fault tolerance. So you could take the entire console server offline, and for a period of time, things are going to keep working. So you've always got time to be able to get things running. But I think I did that live. It was literally a few files, and these files you can literally find in the documentation here in getambassador.io user guide console, and we'll paste these in the sort of the follow-up. But very, very simple. I've now got end-to-end TLS authenticated and authorized secure traffic between my services. And I'll hand back over to you, Daniel.
Cheers, Nick. No, great stuff. Live demos are fraught with danger, so I appreciate you doing them, Nick, because I'm always super nervous when I'm typing in front of people. That's awesome. Shan, can I grab the screen, please? Super. All right. Let me just final. So basically just refreshing a little bit what Nick said there. Nick was like the fantastic demo. Basically, Nick was making a request via Ambassador. Ambassador is forwarding it on. Obviously, there's multiple paths in our demo here, but just one path is being used then. It's forwarding the Envoy proxy running within Ambassador. Ambassador is effectively a control plane, north-south control plane, onto the Envoy there. It is talking to the console-controlled east-west proxies, the sidecars running next to the apps. And you can see I've got a few examples here, but crucially is what Nick said, we've secured the ingress, we've secured like say TLS at the edge, auth and so forth, end user auth. But as Nick said, we've plugged the gaps there. We've secured the encryption, secured the traffic communication between Ambassador and services and other services too. And we've also got that identity thing going on. I think I like Nick saying that the intentions is very powerful. Actually defining service or application level identities and sort of who can talk to who is really powerful stuff. So just wrapping up, in conclusion, whether greenfield or part of sort of app modernization, decoupling your apps and your infrastructure is key. And with things like the mutual like MTLS and identification and so forth, you can deploy things sort of almost wherever, but you can then define their identity. These are the front end, these are the back end, these are the user services, for example. And that decoupling allows you to move things around, move your workloads around, maybe migrate to newer platforms and so forth. It's really quite powerful. But you do need to do this incrementally. So sort of, lift and shift gradual parts of your data center, kind of almost like segment by segment or function by function. And you do want to make sure you do all of this securely. So it's very tempting sometimes just to lift and shift stuff and kind of just put it somewhere else. But where your traffic's flowing from, literally from ingress to services across, Kubernetes to VMs, and there's a lot of things to think about as Nick was showing with his sort of segmentation approach, be it segmentation at the network and segmentation at the service level as well. So handling north, south, and east, west does require different control planes at the moment, although Envoy is kind of handling the data plane effectively and doing a lot of the heavy lifting in this example. The way we configure ingress and the way we configure the service comms is different, and Nick showed you some mappings there with ambassador mappings. You can also get lots of great console information from the HashiCorp docs as well about how you configure all your sort of routes within console and your intentions and so forth there as well. Do think about having an integrated solution. There's lots of stuff going on at the moment around service meshes, but I think we're all aligned on this one, Nico. You really need to group these things together. You need to think about your east-west as well as your north-south, and need to work together really well. Ambassador and Console do bridge the legacy or the heritage apps to the new world. So I'm super excited about that. So working more with the HashiCorp team, we all are at DataWire. Like we think like Console is super awesome. I've used it for many years. Nick and I have worked together in the past at other projects where we use Console, and the combination of these things I think is genuinely really exciting. You get your dynamic routing, you get your MTLS, your identification, segmentation is really powerful, and there's a bunch of other cross-cutting concerns that we've only really hinted at here, but you can pop along to the console docs, you can pop along to the ambassador docs and read more about trying to lift some of these things like essential cross-cutting stuff like rate limiting, like auth, and putting it more in sidecars and putting it more sort of in the ingress as opposed to your apps in particular. So I think that is it, Nick, actually. It's time for, has anyone got any questions?
I got a fun fact.
Log on.
So just kind of drawing on what you were saying, I don't know what, it's a fun fact for me anyway, but Daniel and I actually first met when we were working for the same company, which was a company based out in London doing a microservice transformation about 4 years ago.
Yeah, I think so, 2014, 15, yeah.
Yeah, and Console was the core component in that sort of microservice transformation, which went incredibly successfully. Yeah. Otherwise, I guess I wouldn't have been able to move over to HashiCorp and you over to DataWire. We would have both had our cards marked and.
Agreed. We did a few presentations. People liked some of what we said, so I think we did all right there, didn't we? We learned a bunch of lessons, and then we definitely shared like a few of our mistakes as well, didn't we? And the overall kind of thing. Console was fantastic, as in we did. There's a few other bits where we learned a lot of lessons the hard way, as we all do as engineers.
Awesome. Thank you, Nick and Daniel. At this time, we would like to open it up for any questions, so feel free to enter your questions in the chat box. And while we're waiting for audience to type in their questions, Nick and Daniel, do you guys have anything else you want to add or you want to re-emphasize?
Yeah, and there was something that I didn't show, which was probably due to making an assumption that everybody knew what was going on. But whilst we're waiting for some questions, maybe it's worthwhile literally just quickly showing the sort of the component of being able to secure my website with Console Connect as well, because it does need to be a two-part approach. It's really complicated. I had to add this annotation. And what that annotation does using the Kubernetes injector it basically creates me an Envoy sidecar proxy and sets everything up, connects it all up with the console servers, configures everything for me, and basically enables this pod to participate in the console service mesh, and therefore to be able to receive requests from the Ambassador API gateway. So yeah, I glossed over that, but it is as complicated as adding a single line there. Maybe also, just while we're waiting as well, like the other thing I think which is worth checking out, and we presented a really simple example here. We are somewhat sort of challenged for time, but once you're using Ambassador and Console, the number of features that Ambassador has it's quite sort of astounding. You've got the ability not just to work with HTTP, but with gRPC-based services. You can set up very, very complicated routing, so it doesn't just have to be a single service. You can have multiple different services which are routed off the sort of the same path. You've got the ability to set up auth and rate limiting. SNI, if you want to be able to do transparent HTTPS proxying. SNI is really, really important if you want to sort of bridge between two things, because without SNI, what you're going to be doing is potentially encrypting and decrypting a connection to be able to discover the host. But with SNI, you've got that ability without doing the encryption and decryption. Controlling various reliability patterns, timeouts, rate limiting, circuit breaking, looking at things like canaries, distributed tracing, and some really cool stuff around traffic shadowing, which I'd love to do a demo on that with you, Daniel, one day too.
Yeah, it's very cool, Nick, actually, like the ability to split traffic. I mean, at all levels of the mesh. I mean, Console, I'm thinking, is embracing that as well. But we definitely see a lot of folks doing really cool things for like basically trialing stuff. So splitting off, like copying, duplicating traffic that's coming into the cluster, and then like basically doing experiments. You don't have to return the results to the users. You can kind of hide the results for your own consumption, check it works. But yeah, Nick, I'm up for that. Sounds good.
Awesome. So sorry for interrupting you guys. We do see some questions coming in. The first question is, you guys mentioned moving towards the proposed architecture step by step. What will be the right place to start? And how does the hybrid situation work until you are in pure service-based separation?
I mean, it works quite well. The key thing is that you start small. And if you think about it from the perspective of, even if you implement a service mesh in a very, very small part of your system, you've got better security than you had before you didn't have the service mesh. So you don't need to take a big bang approach. And I thoroughly recommend that you do things gradually, because with any tool, learn how to operate it.
Yeah.
Start slowly. And I definitely recommend doing that. Just enable a couple of services at first, and then slowly, as you gain familiarity and confidence in the tooling, and start expanding it outwards.
Yeah, I'll plus one on that, Nick. I mean, you definitely can, if you don't want to go like MTLS, like first off, you don't have to do that. But in some ways, to your point, Nick, it's almost so easy with Console, particularly if you're going towards Kubernetes, that kind of it's a no-brainer to do it. But I know, like with other projects I've worked on in the past, like exactly what you're saying, that we incrementally rolled it out, and just getting dynamic service discovery with Console was great, let alone the kind of MTLS. So I definitely think it's a great question, and like, definitely it depends on your context in terms of like, be very clear about your goals, about what part of the system you're working on, what you want to get from them, and then like as Nick said, like something we learned probably from previous projects, Nick, and it is go incrementally, softly, and learn as much, because it's like Envoy and Kubernetes is fantastic technology, but it's often new for folks if they're bringing this stuff into their stack. Like for example, Envoy, we haven't really talked about observability, but offers fantastic observability. But again, you've got to learn how to read these metrics and use them to create alerts and things. So it, like definitely you and I, Nick, when we first started leveling up with Envoy and other things, it just took a bit of time, didn't it? So do go incrementally. I think it's great advice.
And there's no reason at all that you can run a service mesh and not service mesh at the same time in your infrastructure as well, because ultimately you want to start doing things like only binding your application services to localhost. So the only communication that can happen is between the data plane and the application. But whilst you're doing the implementation, as I said, you've got the same level of security. The key thing is to learn how to use the tool and to be comfortable with it. So you could have service mesh traffic and not service mesh traffic whilst you're doing your testing and your sort of slow deployment. So there's a number of different ways to cut that cake.
Yeah, as a shameless plug as well, I've got a part 1 of a blog post on the Ambassador blog that talks about, say, starting at the ingress. Obviously, we're a little bit biased with that, but as in putting Ambassador in Kubernetes and then routing with Consul now to, be it VMs, be it bare metal or whatever. So we've obviously worked with another, again, slightly biased there, we work with a number of companies that do start at the ingress and kind of work down through. So they get Ambassador in and they add like centralized auth and things, and then they start rolling out other bits and pieces like with Consul down the way. And blog posts coming, and probably you and I, Nick, probably some like I know I talked to you about sort of segmentation and rolling that stuff out. I think that's very complementary to that kind of stuff. So there could be a future combined blog there, I reckon, couldn't there? Because it's a great question.
Awesome. So the next question I think is for Nick. Consul used Envoy for the proxy. Why now the proxy built into Consul? Is Envoy the standard proxy?
I think the industry in general is centering around Envoy as a standard. So the key difference between the built-in proxy and the built-in proxy is a perfectly good tool. Don't get me wrong, but it is only layer 4. So you're only going to be able to identify and authenticate TCP connections. It's not layer 7 aware, whereas a lot of the patterns that we kind of can benefit outside of just pure security when it comes to using a service mesh, those reliability patterns, they really need to be layer 7 aware, and Envoy is that layer 7. So for us, Envoy is a great tool. It's open source. It's CNCF. Why would we reinvent the wheel? And I think that was the question we asked ourselves when there was such a great tool out there. We're an open source company. Why wouldn't we just promote and use another open source tool? And the answer was there was no reason at all why we shouldn't. The kind of the main reason, I suppose, why you may want to use the built-in proxy is if you're running in Windows. So at the moment, Envoy is predominantly Linux based, whereas our built-in proxy, because we wrote it in Go, it'll run in Windows and all sorts of the other platforms that Consul will run on. But the key difference, you're only going to get layer 4. You're not going to get layer 7. You're not going to get the observability, because we as a company believe that Envoy is the way to go. It's light, it's fast, it's reliable, and everybody uses it. So it's incredibly battle tested.
We had exactly the same thing, Nick, with Master. The reason we chose to build around Envoy was because of the layer 7 stuff. Like a lot of protocols these days are layer 7. So in terms of even like gRPC, you're multiplexing over a layer 7 connection. So unless your load balancer or your proxy is L7 aware, you're going to have weird stuff where you might get hot shards in your cluster because like the sort of L4 doesn't realize what's going on. It's just proxying that one connection through to one service. So we had exactly the same kind of motivations. And on that, there's a great blog post on the HashiCorp blog that talks about the future of Consul. I was reading that the other day, and all the cool stuff there, observability, some other cool stuff, like a lot of it is driven with Envoy, isn't it, in terms of being L7 aware. So if you haven't seen, all the people listening, if you haven't seen the HashiCorp blog around the roadmap for Consul, super exciting, check it out, and it will give some more hints as to, I think, the power of Envoy.
I know the person who wrote that blog post pretty well, so I really recommend checking that blog post.
I didn't actually look who wrote it, Nick. So I'm guessing now, of course.
Cool. That's all the questions we have so far, and we're almost at the top of the hour. So thank you, Nick and Daniel. I hope everyone enjoyed today's webinar and have a better understanding of how Consul Service Mesh working together with Ambassador API Gateway to secure the traffic for your hybrid environment. And finally, as mentioned at the beginning, this webinar was recorded, and we will make the recording available on our website after post-processing. So I will send an email to everyone who registered with the recording link. Have a great day. Goodbye, everyone. Thank you. Thanks, Nick,
Thanks a
and
lot, everyone.
thanks. Yeah, thank you
Cheers.
guys. Bye bye.